Homework 1. In question number 1, it gives you the rate of reaction to be 0.2. It asks you to calculate individual rates, including consumption, formation of A, B, C, D. The relation between the rate of reaction and the individual rates is as following. The individual rates divided by the coefficient of each substance give you the reaction rate. In this case, is 0.2 millimole per liter per second. On the other hand, using the rate of reaction, how do you calculate individual rates? You multiply by the coefficient. So for A, you multiply by 2, because here the coefficient is 2. And B is 1, and C you multiply by 3. And therefore, the answer is 0.4 millimole per liter per second for reaction rate consumption A, for B 0.2, for C 0.6, and for D 0.2. So the conclusion is, if we know the rate of reaction, we multiply by the coefficient to give you individual rates. In question number 2, the rate of consumption of A is given. It asks you to calculate the rate of formation or consumption of B, C, D. In other words, we know one individual rate. We want to calculate other individual rates. So again, looking at this relation, the individual rate for A in this case is given. We want to calculate other individual rates. But first, we want to calculate the rate of reaction. Okay, for individual rate, you divide by coefficient. In this case, for A is 2, so you divide by 2. The reaction rate, or the rate of reaction, is calculated to be 0.1. With this reaction rate, we then multiply the coefficient of each of the individual coefficient. You get other individual rate. For B, you multiply by 1. For C, multiply by 1. For D, multiply by 3. Okay, and therefore the answer is 0.1 for B, 0.1 for C, 0.3 for D. And so the conclusion is, to know one individual rate, in order to calculate the other individual rates, we first calculate reaction rate. All right, so in this case, you divide by 2 to get the reaction rate, and then you multiply by the coefficient to get the other rates. In question number 3, it tells you the rate law for the reaction is this equation. So this is the rate law for reaction rate. It asks you to express the rate law in terms of rates of formation and consumption of A and D. So this question tells you the reaction rate. Instead of a number, it gives you an equation. It asks you to calculate the individual rates. The method is similar to the first two questions. So the relation is here, individual rates and reaction rate. So in this case, reaction rate is given. Okay, the reaction rate is given. It asks you to calculate individual rates A and D. So from reaction rate, you multiply by the coefficient. All right, for A, you times 1. All right, and for D, you times 3. And therefore, times 1, that's the same as the rate of reaction. For D, you times 3. So 3 times Ka to the third power times B. So again, reaction rate is given. You multiply by coefficient to get other reaction rates. This question is just give you equation instead of a value. In question number 4, it gives you the rate law in terms of rate of consumption of A. Alright, is this equation. So we know the individual rate. Instead of a number, it's an equation. It asks you to write rate law in terms of reaction rate. The relation is the same. You know individual rate, in this case is A. You want to calculate the reaction rate. So here you divide by the coefficient. So for A, coefficient is 2. And therefore you divide by 2. And that gives you the reaction rate is half KAB. What is the unit of K? To calculate unit of K, we look at this equation. The left side is the reaction rate. So you can write as reaction rate is K, A, and B. Okay, and therefore the unit of K should be the unit of V divided by unit of A divided by unit of B. And therefore here is the equation. So the unit of K is the unit of V. Okay, unit of V divided by unit of A divided by unit of B. What is the unit of V, the reaction rate? It's the molarity per second. Okay, molarity per second, and molarity is moles per liter, and so you can write as moles per liter per seconds. That's the reaction rate unit. What is the unit of A and B? They are concentrations, and therefore that's the molarity. So the unit of A is molarity, unit of B is molarity, which is moles per liter, moles per liter. Okay, and therefore if you use reaction rate unit divided by molarity and divide by molarity, you should get seconds and molarity per seconds, or it's liter per mole per seconds.